Okay, hi, hello everyone, and welcome to this live session where what I'm doing is I am going to be answering every question in the new book that I've made. As you can see on the screen, it's quite an exciting time. Here is the cover of the new book. I have recently just got it back from its final proofread, and what I want to do before I officially make it available for sale so that you can complete it at home, go through it and do what you want. I just want to complete the book one last time to make sure that all of the answers and the questions are correct. And I thought to myself, why not do this live so that you guys can join me, and if you want to watch through and have a go yourself, that will be something you can do. So if you're joining this video, in this video, what I'm going to be doing is I'm going to be answering every question that there is in my functional skills level 2 maths book, just to check that everything is right before it is finally released. So if you've got your functional skills exam coming up, or you want to do something to help yourself prepare, watching this video will be useful to you, because in it we are going to be covering absolutely everything that is covered in the functional skills maths curriculum. Now, I will caveat that I'm unlikely to get through this all in one session. I've been putting quite a lot of work into this book now for a few years, and I would say that when I've run through all the questions by myself, it's taken me a few days to do that, working pretty much flat out on it. So this video is part 1, and what I will do is I will timestamp it so that you can click along. So make sure, if you're happy with a topic, you look down below and then you can just click over to the next topic rather than having to watch me do every question, unless you'd like to watch me do every question, and that is something that will be good too. Also, whilst you're here and you are watching it, because this is well, it's a bit of a promotion, but because this book is going to be printed, if you do spot anything that I have, any mistakes that I've made, please add them in the comments. Please actually put the question number and what you think the mistake was, and if the mistake was in the answers or not. Okay, but I'm pretty confident that this is now all correct. It's proofreading is an absolute nightmare. So, but okay, let's begin. So, let me just actually, before we begin, I'll just quickly show you. I'm quite proud of this. So this is the cover, and then this is. Let me get the document. Here we go. So is that the one that I wanted? No, that's not quite right. Let me get this. Let me get 98 scaled. So here we go. I've got it on the answers page actually, because that's the page that I'm going to be using, but I'll come back to that in a second. Exit full screen. We'll have it full screen like this. Okay, so these are the answer pages, but here we go. That's page 344. So I scroll to the start. We can have a little bit of a look through the book before I begin. So here it is. Here we go at the start. So the start of the book, it's just got an author's note. Let's change the view of this. So it's not the most dynamic video. Hello, and thank you for joining. The person that's joined, that's really nice. Let me see, what am I trying to do? I'm trying to go to view. I'm on continuous scroll at the moment, so zoom out, single page. So here we go. This is how the book is going to look. So we've got the contents at the front. As you can see, these are the 70 topics that we've covered. And then at the end, we've got the answers and the index. And what I've done is I have formatted all of these pages to look like this. So if you notice these QR codes, these are going to be where you can scan them and they link directly to the videos that are available on each topic. So they all work. That has been approved. What I now need to just check one last time is that all of the answers to every question are correct. And so the way I'm going to be doing this is by answering all the questions. So let me get this page to the answer one. Let's see if I can just do it like this. Here we go. This is going to take a little bit of time, but you're kind of getting a feel for what the book looks like. It's it's been quite interesting. I've had quite a lot of students over the last few years that have just been seeing some of these, and so they've all been part of the parcel of kind of tweaking these and making sure that the questions make sense as well. So hopefully in a few weeks you'll be able to buy this if it's helpful to you. All of these questions are actually still available to you for free on the website crackmaths.co.uk. I just, really weirdly, what I discovered was it's actually cheaper to print it out, to buy it as a book printed on Amazon or like another provider than it is to print it out at home. So that's why I've been doing this. So here's the answers. I want them to be, I want to have that over there so that I can do that. Let me go back to my screen share. Here we go. Right, so this is the contents. Let's now get to the first stage. Okay. Here we go. So, right, and I'm just going to begin now answering these. If you've got any questions whilst I'm here, feel free to ask me. But otherwise, I'm going to plod through and see how it goes. Okay, so question 1 says, arrange the following numbers in ascending order. So we've got minus 150, 75, minus 200, 100, and minus 50, and 25. Okay, so ascending order is smallest to largest. So the smallest number, we've got minus 200, minus 150, minus 50, 25, 75, and 100. Okay. What I'll do is I'm going to do a full page first and then I'll mark them. So next one I've got, arrange the following numbers in descending order. We've got, so that's descending is largest to smallest. So it looks like we've got 300 here. Then 150. Then 50. Then minus 25. Minus 100. Minus 250. Okay. Then we've got here, arrange the following numbers in ascending order. So that's going to be smallest to largest. So smallest is minus 300. And then minus 75. Minus 50. 25. 100. And 200. Okay. Right, let's try this next one. Arrange the following in descending order. So that's largest to smallest. So the largest one here looks to be 250. And then we've got 100. And then we have 50. And then we've got minus 25. And then we'll have minus 150. And then minus 200. Okay. Right, question 5. Arrange the following numbers in ascending order. So we've got here, ascending is smallest to largest again. So the smallest is the largest negative. So that's the one that's furthest away. So we've got minus 250. We have minus 100. We've got minus 50. We have 25. We've got 150. And we've got 300. Okay, right. Let me get the answers up and see if those are correct. So here we go. Right. And then screen. I feel like this must be like ASMR. It's going quite slowly. Right, so we've got here, yep, minus 200, minus 150, minus 50, 25, 75, 100. Yep, so we agree with that one. Then we've got 300, 150, 50, minus 25, minus 100, minus 250. Let me see if I can enlarge this a bit just so you can kind of see where I'm going at with these. So here we go. I'm on these ones here. So that's 2 that's correct. Number 3, I've got minus 300, minus 75, minus 50, yeah, 25, 100, and 200. Okay, yeah, that's good. Next one, question 4, we've got 250, 100, 50, minus 25, minus 150, minus 200. And then next one we've got here, minus 250, minus 100, minus 50, 25, 150, 300. Okay, so that is the first set of 5 complete. Let's move on to the second set. So I will make this screen large again. Here we go. Right, let's go back to, change my colour back to black and have a look at these ones. So here we have arranged the following numbers in descending order. 200, minus 75, 100, minus 350, minus 25. So descending order is largest to smallest. So the largest is the 200. Then we have the 100. Then we have the 50. Then it will be minus 25. We'll have minus 75. We'll have minus 300. And that's that. Next one we've got is arrange the following numbers in ascending order. So that's smallest to largest. So we'll have minus 200, minus 150, minus 50, 25, 100, and 250. Okay, next. Arrange the following numbers in descending order. So that's largest to smallest. So we've got the largest one is 150. Then it will be 50. Then it's going to be 25. Then we'll have minus 25. Then we'll have minus 100. Then we'll have minus 250. Okay, question 9. Arrange the following numbers in descending order. Okay, so here what we're going to have is... oh gosh, very close. I almost read the wrong thing. Arrange the following numbers in ascending order. So 9, so that's smallest to biggest again, so that's minus 300. We've got minus 200. We've got minus 50. We have 25. we've got 75, and we've got 100. Okay, right, next one we're going to have here, arrange the following numbers in descending order. So we've got descending is largest to smallest, so 250, 100, we've got 50, we've got minus 25, we've got minus 100, and minus 150. Okay, so let's find out if they agree with the answer scheme. So here we go. I'm going to go to the book, and then we just need to get this back here as well. Oh, no. Here we go. Let's see if this matches up. So we have got question 6. So we've got 200, 100, 50, minus 25, minus 75, minus 300. Okay, that's great. For question 7, we've got minus 200, minus 150, minus 50, 25, 100, 250. For 8, we've got 150, 50, 25, minus 25, minus 100, minus 250. For 9, we have minus 300, minus 200, minus 50, 25, 75, and 100. Okay, and then on this next one, what we have is we've got 250, 100, 50, minus 25, minus 100, minus 150. Okay, great. That is the first set of practice questions for the first round for the first topic. So now what we've got next is we've got these scenario questions. Okay, so let me make this full screen again, and then we will complete these. Okay, so here we go. So we'll go back to black. So these scenario ones, they've tried to make a topic that's like real life for each one. So this one, the first one, we've got temperatures, and then we've got money. So let's have a look at these. So arrange the following temperatures in ascending order. Yep, I'm happy with how that reads. So let's have a look. Ascending is smallest to biggest. So the smallest one there looks to be minus 5. Then we've got minus 2. Then we have 3. And then we have 7. Okay. Number 2, we've got place the following account balances in descending order. So that is largest to smallest. So the largest looks to be the £500. Then we have no pounds here. Then we have minus £100, and then we have minus £300. Okay, let's have a look at question 3. So question 3 is arrange the following elevations in ascending order. I might need some more water. Hello, hey, hi Joseph, good luck. This so I'm moving quite slowly through these, but if you want to join in, feel free. But yeah, that's exciting that you've got that exam tomorrow. Possibly. Right, let me keep going with this. So arrange the following elevations in ascending order. So ascending is smallest to largest. So the smallest elevation will be the minus 800 feet. And then we will have the minus 300 feet. Then we're going to have the 0 feet. And then we're going to have the 2,000 feet. Okay, question 4. Place the following distances from a starting point in descending order: 15 miles, 100 miles, 17 miles, and 50 miles. Okay, so we've got here descending order is going to be largest to smallest. So the largest of these will be 100 miles. Then we're going to have 50 miles. Then we'll have 17 miles. And then after that we'll have 15 miles. Okay, so question 5. Let's have a look at this one. So it says here, arrange the following bank account balances in ascending order. So that means smallest to largest. So the smallest is going to be the largest negative. So the smallest one here is the minus £6. Then we'll have the minus £3. After that, we will have the minus £1.50. And then we'll have the £4. Okay, so let's load this up and see if we have got these answers correct. So here we go. And then we get here. There we go. And we can mark these. So first we've got minus 5, yep, minus 2, 3, 7, great. The next ones we've got, we're going to have 500, 0, minus 100, minus 300. The next thing we're going to have is here, we've got minus 800 feet, minus 300 feet, 0 feet, I'm reading over here, 2,000 feet, yep. Question 4, we've got 100 miles, 50 miles, 17 miles, and 15 miles. And then here we've got minus £6, minus £3, minus £1.50, and £4. Okay, great. That's that round correct. Okie dokie, let's have a look here at these next ones. Let me get this to full size again. So here we go. Place the following temperatures in descending order, which will be 8 degrees, minus 2.2 degrees, okay, minus 5 degrees, 3 degrees. So descending again is smallest to largest. So, no, descending, sorry, no, descending is largest to smallest. So the largest temperature is the 8 degrees. And then we've got the 3 degrees, which is the only other positive one. Then it will be the minus 2 degrees. And then it will be the minus 5 degrees. Question 7, we're going to have here, arrange the following bank account balances in ascending order. Okay, so we've got here minus 9,000. Yep, actually that first one is going to be the smallest, ascending. So minus 9,000 is the smallest. Then it will be minus 4,000. Then it will be 0. And then we'll have 6,000. Okay, then let's have a look at 8. So here we have placed the following weights of the objects in descending order. So descending order is going to be largest to smallest. Okay, so descending, the largest one here is the 9. Then we have the 2. Then we have the minus 3. Then we have the minus 12. Okie dokie. Right. Question 9. Arrange the following ages of family members in ascending order: 19, 7, 12, and 57. So ascending is smallest to largest, so the smallest is the 7. And then we have the 12. Then we have the 19. And then we'll have the 57. Okay, right. Last question for this section. So here we go. We've got place the following distances from a city centre in descending order: 2 miles, 15 miles, 8 miles, and 13 miles. Actually, I'm going to do a little bit of editing here. So, although this is fine, this question, I would prefer it if this 8 was on the next line. So I'm just going to change that. Here we go. So let me just edit that. There we go. So yeah, I've actually made this book in PowerPoint, so or Keynote. So it's quite interesting to have done, but it's worked well. So yes, let's continue on. Back to the remarkable screen share. So, right. Okay. So I've changed that now. That's a useful thing to have spotted. I can make a note that that's been changed. So let's now place them in order. So we've got here descending largest to smallest. So that's going to be 15, 13, 8. Yeah, see, it's good that was done. 8, 2. It's nice that changes are made. It means it's all worthwhile. Okay, right. Let's go back to the preview and get the mark scheme. Okay, and just to find out if we agree with these, here we go. Let's get these marked. Okay, so we've got 8, 3, minus 2, minus 5. We've got minus 9,000, minus 4,000, 0, 6,000. We've got 9, 2, minus 3, minus 12. We've got 7, 12, 19, 57. And here I've got 15, 13, 8, and 2. Excellent. Okay, well, we've completed topic 1, both the practice questions and the scenario. So that takes us on to the next one here. So now here's the moment of truth with these ones here. Do I do these without a calculator or with a calculator? The question is, I will do them without a calculator just because people are watching and it might help. Okay, so this one here, it says, what is the sum of these two numbers here? So we've got 4, 5, 6, add 7, 8, 9. Okay, so we've got 6 add 9 is 15. 5 add 8 is 13, add 1 is 14. And then 4 add 7 is 11, add 1 is 12. Okay, I am actually, because the purpose of this is to double check the answers for the book, I'm going to check this on my calculator right now as well, and then we will double check it with the answers in the book also. So 4, 5, 6, add 7, 8, 9. Yep, so that agrees with my calculator, and we'll go back and check it with the answers shortly. Okay, let's have a look at question 2. So we've got 1, 2, 3, add 4, 5, 6. Okay, 3 add 6 is 9, 2 add 5 is 7, 1 add 4 is 5. Let me just double check on my calculator. Yes, this agrees with the calculator. Okay, and let's go on to question 3. So here we've got 6, 7, 8, add 9, 0, 1. 8 add 1 is 9, 7 add 0 is 7, 6 add 9 is 15. Okay, and then just to double check on the calculator, 6, 7, 8, add 9, 0, 1. Yeah, the calculator agrees with that. Okay, right. What is the result of adding 234 and 567? Okay, so let's do this. 2, 3, 4, add 5, 6, 7. Here we go. 4 add 7 is 11. 3 add 6 is 9. Add 1 is 10. 2 add 5 is 7. Add 1 is 8. So this one should be 801. And I'll double check this with the calculator as well. Yay! Okay, right. Find the total when you add 7, 8, 9 and 1, 2, 3. So 7, 8, 9, add 1, 2, 3. So 3 add 9 is 12. 8 add 2 is 10. With the 1 is 11. 7 add 1 is 8. 9. Let me double check. 7, 8, 9. Add 1, 2, 3. Yep. Okay. Right, now let's check that that's the same with the mark scheme. Here we go. So we're now looking at these ones. I'm going to actually just fix this one to permanently pen red. Okay, so first one is here. 1, 4, 1, 2, 4, 5. Yep. 5, 7, 9. 1, 5, 7, 9. 801 and 912. Okay, great. Let's try the next round. Okay. Calculate the sum of 345 and 678. So we've got 3, 4, 5, and 6, 7, 8. Okay, so 5 add 8 is 13. 7 add 4 is 11. 12. 3 add 6 is 9. With that is 10. Okay, let me check on my calculator. Yep, that agrees with the calculator. Let's do question 7. Seven add 0. Okay, let's try with the calculator. Yay! Right. Let's try this next one. Find the total when you add 901 and 234. Let me just check with the calculator. Okay, I'm going to read these ones out again now, just to see if they make sense. In a race, runner A finishes with a time of 421 seconds, and runner B finishes with a time of 589 seconds. What is the total time taken by both runners? Yep, I'm happy with that. Okay, let's check. Question 2. The temperature in a furnace is 378 degrees Celsius, and it is increased by 256 degrees Celsius. What is the new temperature? Okay, so increase means to add on. So let's do this. Right, let's see if that's right. The calculator agrees. Let's try question 3. A company produces 743 units of a product in the morning and 512 units in the afternoon. How many units did they produce in total? So we've got here 743, add 512, 5, 5, no, 7, yeah, 2, 1. Okay, let's try this. Yeah. Just while I'm here, I noticed that there's someone watching. You might be able to help me out. Do you think that the comma in these two questions makes them read funnily? So if I said here, in a race, runner A finishes with a time of 421 seconds, and runner B finishes with a time of 589 seconds, does that comma need to be there? That's the question. I don't think it ruins it, but I think it's okay. I'm going to leave it because it's been left there after the proofread. Right, question 4. A car travels 567 kilometres on Monday and 432 kilometres on Tuesday. How far did the car travel in total? Okay, let's work that out. So 5, 6, 7, add 4, 3, 2. Let's add these together. So 7 add 2 is 9. 9. Ooh, 9, 9, 9. That's cool. Right, 5, 6, 7, add 4, 3, 2. Yep, 9, 9, 9. Okay, right, question 4. A school has 456 students in the sixth form and 678 students in the lower school. How many students are there in total? Okay, so let's change that. So let's do 4, 5, 6, add 6, 7, 8. Okay, and let's work these out. So 4, 5, 6, add 6, 7, 8. Oh, so 14, 13, 10, 11. Okay, and that agrees with this on the calculator. Okay, I've decided I am going to get rid of that comma. I think it doesn't make sense because these last 3 questions don't have the comma with the and. So let's remove that quickly because I think that did make it harder for me to read. Yeah, here we go. In a race, runner A finishes with a time of 421 seconds, and runner B finishes with a time of 5. Yeah, so that comma, I think, ruins the flow. And I believe that this comma here ruins the flow as well. Okay, right. If you watch this and disagree, please let me know and I will change it back. But I think that is better from reading it out loud. Okay, now let's have a look at the mark scheme to check that that's all okay. And then we'll probably be okay. 1 second. So, scenario 2, 110 seconds. Okay, here we go. This one, 634 seconds. This one is 1,255 seconds, and that units even, that agrees. 999 agrees, and 1,134 agrees. Yes! Okay, right. Let's go on to the next round. So here we go. Let's move over here. Right. Question 6. A store sells 589 books in the fiction section and 345 books in the non-fiction section. How many books were sold in total? Okay. Okay, and then check on the calculator. The calculator agrees. A construction project, question 7. A construction project requires 678 bricks for one phase and 421 bricks for another phase. How many bricks are needed in total? Okay, so here we go. 8 add 1 is 9. 7 add 2 is 9. Here we go. I'll just check with the calculator. Yeah. Question 8. We have a farmer harvests 743 kilograms of wheat and 567 kilograms of corn. How much produce did the farmer harvest in total? Yeah, I think that's fine. Maybe it should be, what was the total weight of the produce, the harvest? I think it's obvious. It's fine. 743 plus 5, 6, 7. Here we go. 3 add 7 is 10. 4 add 6 is 10 as well, with the 1 is 11. 7 add 5 is 12, 13. Okay, here we go. Let me check on the calculator. Yeah, and the calculator agrees. Let's have a look at number 9. So number 9 says, a company ships 512 packages in the morning and 589 packages in the afternoon. How many packages did they ship in total? Okay, so we've got 512, add 5, 8, 9. Let's work this out. 2 add 9 is 11. 1 add 8 is 9. Add another one is 10. 5 add 5 is 10. Add 1 is 11. Okay, so that should be 1,101. Let's try that out. Yeah. Okay. Here we go, question 10. An office has 456 chairs and 743 desks. How many furniture items are there in total? So we've got 4, 5, 6, add 7. So we've got 9, 9, 11. Right, sorry, I've got to go top up my water. I'll be back. Okay, right, let's continue. So let's check these out. 4, 5, 6, add 7, 4, 3 equals. Okay, perfect. Now let's mark this round. Oh no, that's not what I wanted to do. Okay, so question 2, question 6. Yep. 934 agrees. 1099 agrees. 1310 agrees. This agrees. And this agrees. Excellent. Okay. Number 3. Okay, this one's going to test me. Long multiplication, it's always a place for slipping up. Right, let's go here. So what is the product of these two numbers? So I'll use the grid method and then I'll check on the calculator. So we've got 4, 5, 6. Oh my gosh, 1 second. Let me draw the lattice first. Okay, so we've got here 12, 18, 10, 15, 8, 12. And then if we add down the columns, the rows like this, so we've got 8. 2 add 1, add 5 is 8 as well. 1 add 1, so that's 4. 1 add 8, add 1 makes 10. So there's nothing there. So this equals 10488. So 10,048. Let's see if the calculator agrees. 23 times 456. Whew, and it does. Okay, right. Next one. We've got here. Draw the lattice again. So 4, 5, 6, 34. Divide all of these in 2. So 3 times 6, 24, 15, 20, 16. So that'd be 4. This one is 10. So just think about that one there. 6, 8, 14, 15. Think about 1 there as well. So 1, 4, 5. And then a 1. So I've got 1, 5, 5, 0, 4. Really, this is quite. Let's find out. 34 times 5, 6, 7. Oh no, that went completely wrong. Oh dear, let's try again. Right, 1 second. Oh, I wrote down the wrong numbers. That was it. Okay, fine. Five, 6, 7, 34. I did think when I saw it didn't end in 8 that it looked unlikely to be the correct. So 21, 28, 18, 24, 15, and 20. Okay, now we can add these up. So we've got 8, 6, 7, 10, 12, 6, 7, 8, 9, 1. Yes, excellent. This one agrees with the calculator this time. 1, 9, 2, 7, 8. Let me just move that out of the way. I can blame that. And now to check it with the calculator. Yep, that's good. And then just to check on the calculator. Excellent, and it agrees. Okay. 8, 9, 1 second. Excellent, and that agrees with the calculator. So let's now mark these. Oh, no. Okay, so the answer to this one around here. Oh, yes, excellent. Okay, another clean page. Up to page 14, only like 380 in the book. Okay, well, we'll keep going. So, next one. When you draw these grids, you just make them, 1 second. You just make them the size that you require. So these all seem to be 3 by 2 numbers, which are the most common kind of long division question you might get. So 9. Always nice when you get a 0. Let's try this. Excellent, the calculator agrees. I'm actually pleasantly surprised with my lack of mistakes, so this is very good. Not in the book. I've really double and triple checked this book. Just when it comes to calculations, it's always easy to slip up. Okay, just check the calculator. Excellent, and the calculator agrees. Okay. Next one. Nice, we've got a 0. Makes it lovely and easy. Calculate the product of 12 and 345. Okay, and the calculator agrees. What is the answer when you multiply 54 and 510? I realise I really should be getting in the habit of reading these out actually if I'm proofreading it, because there's things like this is a question, that's a statement. Statement is nice actually, but it's good to see the different words as well. Product, result, answer. Okay, right, so let's do this last one. What is the answer when you multiply 54 by 510? This one was quite nice as well actually. No real complicated sums in that one. And let's see if the calculator agrees. And it does. Okay. Now let's double check with the answer scheme. Here we go. So we're looking around here. Yep. 70278. 10,947. 21,060. 4,140. 27,548. Hey, there we go. Up to 15 is all good. Right. Okay, we can go on to the next page now of answers as well. So here we go. We've got the question 3 scenario rounds. So let me keep going with this. Okay, let me read these ones out just to make sure that they make sense. A store sell. We've got the dubious comma again. A store sells 456 packs of cookies, with each pack. Oh, I like it here. With each pack containing 25 cookies. How many cookies are sold in total? Yep, I like that. I like that comma. Okay, and it's got the question mark. Perfect. Right. So, a store sells 456 packs of cookies, with each pack containing 25 cookies. How many is sold in total? So here we go. This is really testing my mental maths. Here we go. Okay, and we agree with the calculator. Let's try here. Question 2. A farmer has 37 fields, and each field has 589 apple trees. How many apple trees are there in total? Okay. I always second guess 8 times 7. Oh, I went wrong. Right, let's find out where it went wrong. Let's see. So 2. This is where it's gone wrong. Oh dear, that's where I went wrong. If you spotted it, well done. 7 times 9 isn't 72. It's 63. Okay, right. So we've got 3, 12, 19, 6, 16, 17, 7, 10, 11. And then that makes 2. Here we go. So 21,000. Great, and that agrees with the thing. Okay, with the calculator. Let's have a look at this one. A company produces 48 crates of oranges, with each crate containing 743 oranges. How many oranges are produced in total? Okay, so seven. I went wrong here. I didn't. Where did this go? Oh, I see. Oh dear, that should have been a 2. Making that a 6. Nope, that's not right. 1 second, let me go back. My adding has gone wrong. Let's try again. So let's just check. 12, 24, 16, 32, 28, 56. So we get 4 from this line, 6 from this line, 7, 10, 16 from this line, that's where we went wrong, and then 10, 15 from this line, 3 from that line. So there we go, and that agrees with the calculator. Let's try the next one. A factory produces, sorry, need to make sure we're reading it properly. A factory produces 56 boxes of toys, with each box containing 678 toys. How many toys are produced in total? Okay, so here we go. 6, 7, 8, 5, 6. 40. That's a 6. So 48, 35, 42, 30, 36. Okay, and then 8, 14, 19, 6, 7, 3. Let's hope that this one's right. 3, 7, 9, 6, 8. Let's check with the calculator. Yay! Okay, great. Back on track. Okay, let's try question 5. So a bakery bakes 69 cakes, with each cake requiring 512 grams of flour. How many grams of flour are used in total? Okay, so let's do that. Okay, so let's try it. Let me get my calculator up on here actually. I feel like I'm doing secret things on the calculator and not letting you join in. Here we go. Three, 5, 3, 2, 8. Excellent. So we're happy with the calculator. Let's see if we are happy with the mark scheme. Okay, so this was 3 part 1. Yeah, 11,400. 21,793. 35,600. Oh, ooh. Ah. Excellent. We spotted something. Okay, here we go. 35,664. So this here does not agree with what I've got here. Let's just double check it once more. So let me get the calculator just to see. So we have got 48 times 743. Excellent. Right, okay. Mission worthwhile. Okay, so where are we? So I've got to go to the answer scheme, the answer pages. Sorry, I don't know if this is exciting or not. This is probably really... here we go. Right. Perfect. So now, that ties in with what I've got written down here. Okay, which we've confirmed is the right one. And then, what else? Here we go. Right, and now, this is unfortunate. Okay, so this is the PDF, but I know that I fixed that. Okay, we'll fix it all as we go along. Okay, and I'll just circle that and say changed in answers. Okay, there we go. Let's keep going. So the next one, we've got 37968 toys. 37968. Excellent. 35,328 grams. 38,328 grams. Okay, right. Next set of questions. Here we go. Let's bring back the calculator. Okay, so this one says, a construction company builds 78 houses, with each house requiring 589 bags of cement. How many bags of cement are used in total? Okay, so let's do this again. So grid 589. Sorry, I've just got to check something. Five, 8, 9, 78. So that's 63, 72, 56, 64. Oh, we haven't had an 8 times 8 yet. 35 and 40. 2, 14, put the 1 there. 19, put the 1 there. 15, put the 1 there. 4. So here we go, we've got 4, 5, 9, 4, 2. Let's check it out. 5, 8, 9 times 78. Yep, perfect. Okay. Right, question 7. A franchise has 87 shops and each shop has 421 employees. How many employees are there in total? Okay, so we're multiplying them again. Hey, excellent. We agree. Let's try number 8. A warehouse receives 96 shipments, with each shipment containing 567 boxes. How many boxes are received in total? Okay. Excellent, yes. Question 9. A delivery truck makes 34 trips and each trip carries 743 packages. How many packages are delivered in total? Excellent. Yes. Okay. Next one. Question 10. A garden has 45 rows of flowers, with each row having 678 flowers. How many flowers are there in total? Okay, so again, we're multiplying the two numbers together. Yay! They agree. Excellent. Right. Now let's check them with the mark scheme. Oh no, that wasn't what I wanted to do. Right. Yep. Perfect. So let's just, yeah. 25,262. Yeah. Great. Okay. 3 topics done. Right. Now on to section 4. Okay. Let's keep going. Oh, 1 second. Okay, right. So again, I'm going to do these the non-calculator method, and then I'm just going to check them with the calculator just to make sure that they're nice to do. So what is the difference between 987 and 456? So we've got 987 minus 456. Okay. Yeah. Great. Find the result when you subtract 789 from 1234. Oh no! Oh dear! Right, we can see where I went wrong here. I did 12 take away 8 is 5, where 12 take away is actually 4. I think I probably dwelled on this 13 and did 13 take away 8. Okay, but that's why it's good to check. Okay, so that is 445, and that is a confirmed answer there. Okay. Oh, 1 second. Actually, I should write that back in black. So actually, I don't want to confuse the system. Okay, calculate the difference between 876 and 345. So we'll do the smaller from the larger with this one. Oh, it's 1 second. That's interesting. Oh, okay. That's fine. It's not the same question. It's just got the same answer. Okay, no worries. I just thought to myself, I recognise that 531, but this question is different, so that is fine. I haven't repeated a question. Let's check if this answer is correct. Excellent. Okay. So 1, 2. I had some pretty lazy number choices when I was doing this, but it's fine. It's still practicing the maths. So that's 2, 14, 9, 12. 12 take away 5 is 7. 11. Excellent. Remember, if you need more, if you are watching this and you want any guidance on how to do these, there's loads of tutorials on them on the Crack Maths website that you can just follow. They follow the same number system. So excellent. Right, let's check. No, that was what I wanted to do. There we go. 531. 531. 445. 445. 531. 531. 323. 323. 679. 679. Okay. Right. Here we go. Calculate the difference between 901 and 243. 234. No, we can't borrow from 0, so that becomes an 8 first, that becomes a 10, that becomes a 9, that becomes a 1. So 7, 6, 6. Perfect. What is the answer when you subtract 123 from 789? So 666. Let's find out. Yay, excellent. Find the result when you subtract 432 from 901. I think I like the number 901. I feel like I've seen it before. 8, 10, 9, 1, 9, 6, 4. Excellent. Okay, let's try this next one. Question 9. Calculate the difference between 345 and 123. Okay, that seems nice and straightforward. Excellent. Okay, and question 10. What is the answer when you subtract? So we've got 9, 8. Excellent, perfect. So let's mark these. Yeah, we've got that. 667, 666, 469, 222, and 109. Right, I quickly need to nip to the toilet. I'll go. Yeah, alright, it's just slow. Yeah, it's going alright, it's just slow. No, I just had to go. I've only got one person watching anyway. I'm back. Oh, you waited, thank you. Okay, right. Okay, let's get to question 4, scenario questions. Okay, so here we go. That's not what I want to do. I want to go to the next page. Here we go, right. So now we've got scenarios to read through. Okay, let's hope these make sense. Okay, question 1. Sade had 987 apples and she gave away 654 apples. How many apples does she have left? Okay, if she gave them away, that means it's the 654 that's been taken away. So we've got 9. Oh, let's stick to the colour scheme. 987, take away 654. Okay, so that's going to be 3. That's going to be 3, and that'll be 3. Let's double check the calculator. 987, take away 654. Hey, excellent. Okay. Right, question 2. A store had 1,234 books. They sold 987 books. How many books are still in stock? Okay, so we're taking away the 987 from the 1, 2, 3, 4. Okay. And this is going to leave us with, take that away from there, 2, 1. 14 take away 7 is 7. Borrow again. 12 take away 8 is 4. And then we'll borrow this one there. 11 take away 9 is 2. Okay, let's have a look. 1, 2, 3, 4, Takeaway 987. Yeah, excellent. Okay. Question 3. Johnny had saved £876 for a new bike. He spent £109 on other expenses. How much money does he have left? Okay. So he'd saved, well, I don't need to put the, he'd saved £876 and he spent £109. And so we do 6, 1, 7. Here we go. Is that question clear, do we think? John had saved £876 for a new bike. He spent £109 on other expenses. How much money does he have left? How much money does he have left? I think that's fine. Okay. Right, let's work out if that's right. 876 take away 109 equals 676. Yeah. Okay. Right, question 4. A bakery has 1,234 cookies. A bakery had 1,234 cookies. They sold 1,009 cookies. How many cookies are left in the bakery? Okay, so we've got 1, 2, 3, 4. Take away 1, 0, 0, 9. So 2, 1. So that's 5, 2, 2, 0. Okay, let's double check. So the answer would be 225. Let's try 1, 2, 3, 4. Take away 1, 9. Excellent. Great. Okay, question 5. Lisa had 890 marbles. She lost 495 marbles. How many marbles does she now have? Does she have now? Okay, so we've got here 890 take away 495, and this will be 8, so 5, 9, 3, 395. Let's double check. 890 take away 495 equals 395. Excellent, perfect. Right, let's get these marked. Okay. Yep, so 333, 247, 225, and 395. Excellent. Okay, next page. Okay. A company had 500 employees. 234 employees resigned. How many employees are still working in the company? Okay, so let's try this. We've got 500, take away 234. Okay, and let's go with this. We're going to have to borrow from here first. 10, 9, 1. Okay, 10 take away 4. Okie dokie, let's find out. Excellent. Seven. There were 789 students in the school. 150 students graduated. How many students are still in the school? So that's 789. Take away 150. So that's 9. Oh, that's fine. 9, 3, 6. Okay. Question 8. A car had 105 litres of fuel. 49 litres were used during a trip. How much fuel is left in the car? Let's find out. So, we've got 105. Okay, so we can't do that. 191. 15 take away 9 is 6. 9 take away 4 is 5. Let's check. Hey, excellent. That's litres. Okay. Question 9. A box contained 240 chocolates. 123 chocolates were eaten. How many chocolates were left in the box? How many chocolates are left in the box? That's fine. So 240, take away 123. Here we go. That's 7. That's 1. That's 1. 117 chocolates left. Okay, let's try this out. 240, take away 123. Excellent. And that agrees. Next one here, we've got Tom had 1,000 baseball cards. He gave 456 baseball cards to his friend. How many baseball cards does Tom now have? Okay, so we've got 1,000. Take away 456. Okay, so that becomes, well, a 10 up here, that becomes a 9, that becomes a 10, but that becomes a 9, that becomes a 10. Okay, so 10 take away 6 is 4. 9 take away 5 is 4. Okay, let's try it. Get LV out calculator. Okay, so we've got 1,000. Take away 4, 5, 6. Excellent. Okay, let's get these marked. Ooh, division next. Okay, let's do these ones here. So we have got two. I'm going to add this in just in case I upload these employees. Yep. 639 students. Yep. Okay. And now I started doing that anyway. Litres, 56 litres, 117 chocolates, and 544 baseball cards. Ooh, it's actually going all right. There's not been too bad. That's right. So that's 21. Okay, let's get on with some long division. Working out using the bus stop method. Okay, so divide 789 by 3. So 3's into 7, you get 2 3's go into 7, and there's 1 left because 7 take away 6 is 1. 3's into 18 is 6. 3's into 9 is 6, is 3. Okay, 2, 6, 3. Let's just double check. 7, 8, 9 divided by 3. Perfect. Right. So here we go. 4, 5, 6 divided by 7. So 4, 5, 6 is first, so it goes under the bus stop. 7 here. 7 into 4 doesn't go, so we've got the whole 4 left still. So now we're looking at 7 into 45. Ah! Right, 6 times 7 is 42. So 7 goes into 45 6 times, and then that leaves 3 left. And then we've got, oh, 1 second, I just noticed up here it says give answers up to 1 decimal place. So we don't have to continue very far with this. I just noticed this isn't going to go in perfectly. So we're going to get a decimal place here. I'll just put that in for the time being. 7 into 36, well 7 times 5 is 35. So it goes in 5 times with 1 remainder. 7 into 10 goes in once with 3 remainder. 7 into 30, 4 times 7 is 28, so that goes in 4 times with 2 remainder. I'm not going to continue beyond this because they only want 1 decimal place. Oh, thank you. So we only want 1 decimal place, so I'm going to just round this to 1 decimal place. 4 is less than 5, so we don't think about that. So here we go. We're going to say the answer to this will be 65.1. Okay, let's try it on the calculator. So we've got 456 divided by 7. Yeah, and there we go, 65.1, which is what we were getting up here. Okay, right, let's keep going. So here we go. Remember, the number that comes first is what goes under the bus stop. Okay, 4 into 6 goes once with a remainder of 2. 4 into 27 goes 6 times with a remainder of 3. 4 into 38 goes 9 times with a remainder of 2. I've got to add the 0 again there. 4 into 20 goes in 5 times. Okay, so there we go. We've got 169.5. Again, let's check on the calculator. So here we go, we've got 678 divided by 4. Excellent, and that agrees with that. So it looks like we're on the right path. Let's try here, we've got 901 and 5 here. So 5s into 9 goes once, and then that leaves a remainder of 4. 5s into 40 goes 8 times with no remainder. Okay, we're going to have to stick some things here. 5 into 1 doesn't work because 5 is bigger than 1. So that leaves the remainder of this 1. 5s into 10 go 2. So here we go. We've got 180.2. And let's check that out on the calculator. What am I doing? I've been doing this for too long. 901 divided by 5. Yay! Okay, great. So that's all good with that. Last one for this round of 5, then we can mark that. So 2, 3, 4 divided by 9. So 9 into 2 doesn't go, so we've got a remainder of 2. 9 into 23 goes twice, because 2 times 9 is 18. There's 5 left to get you up to 23, so we've got to put the 5 here. 9 into 54 goes 6 times exactly. So our answer to this is 26. And let's check. 234 divided by 9 is 26. Hey, excellent. Okay, so let's continue here. Well, let's just check that these are right. Okay. So first one here, we've got 263. Yep, that's correct. 65.1. That agrees as well. 180.2. 169.5. And 26. Excellent. Okie dokie. Right, so let's go on to the next round. Here we go. Right, so what do we have here? We have got, oh my gosh, divided by 12. Oh dear, it's long division. Okay, right, so let's, right, how am I going to do this? I might actually, I'll do this one by 12 But the next ones I'm going to split up, I think. Yeah, actually, no. I'm just going to do... Yeah, I will just do this one by dividing by 12. So 2, 3, 4, 5 divided by 12. Okay, so into 2 doesn't go. Into 23 goes once, and then with a remainder of 11. How many 12s go into 114? Right, well, 10 times 12 is 120. 9 times 12 is 108. So this goes in 9 times. Okay, and there's 6 remainder. Because 114 take away 108 equals 6. Then we've got 12s into 65. Well, 12 times 5 equals 60. So it goes in 5 times. We need to put in some decimal points. And then, so we've got a remainder of 5. And then we're looking at 12s into 50. Well, 4 times 12 is 48. So that goes in 4 times with a remainder of 2. And it only fits once into 20. We're only doing up to 1 decimal place, so we can stop there. Okay, so we'll call this 195.4. So what we can do is we can then check this out here. So we can do 2, 3, 4, 5 divided by 12. And there we go, 195.4. Excellent. Right, question 6. I think I'm going to split this up. So if you get a number, say for example like 45, I know that 45 is 9 times 5, okay? So if I'm going to do this divided by 45, what I can actually do is this divided by 9 and then this divided by 5, okay? So what I'm going to do, not this divided by 9, then this divided by 5. I can do this divided by 9, and then the answer of that I can just divide by 5. So that's what I'm going to do for this one, because 45 is a bit of a big number. So here we go. Let's do it step 1 first. Okie dokie. So into 6s doesn't go. 6 times 7. 9 times 7 is 63. 9 times 7 is 63. So this goes in 7 times with 2 remainder. 9 times 2 is 18. So that goes in twice with 6 remainder. 9's into 63 goes exactly 7 times. So now what we're going to do is we can then take this answer and divide it by 5. So 727 divided by 5. So here we go. 1 with 2 remainder. 4 with 2 remainder. 5 with 2 remainder. And then 4. So there we go. So we've got 1, 4, 5.4. Let's just check. So 6543 divided by 45. Excellent. Okay, great. So here we go. Let's try this next one. 56. Is 56 in any times tables? I think it's 9 times 6, isn't it? 9 times 6. So what I'm going to do is I'm going to oh god, what's this next one? So 56 is 9 times 6. No, it's not. That's 9 times 4. 56 is 7 times 8. Okay, so let's see if I can. I'm going to divide it by 7 first, then I'll divide it by 8 first, then I'll divide it by 7, because I think it'll probably no, I'll divide it by 7 first, then I'll divide it by 8. No, I'm going to divide it by 8 first, because it will be nicer. It will be nicer. Okay, so 8, 7, 6, 5 divided by 8. So that goes in once with no remainder. That doesn't go in with 7 remainder. 8's into 76. 9 times 8 equals 72. So it goes in 9 times with a remainder of 4. Okay, and then 8's into 45. Well, 5 times 8 is 40. So that goes in 5 times with a remainder of 5. And then 8's into 50. Well, 6 times 8 equals 48. So that goes in 6 times with a remainder of 2. I'm going to have to do a little bit of this because it's not a nice answer. 8's into 20 go twice, which is 16. And with a remainder of 4. So, and 8's into 5. So, okay, right. So we've done the first bit. We've divided by the 8. Okay. Let me just get rid of these numbers here because I need this space for this bit. So this time I've got 1095.625 and I'm dividing that. We've done divided by 8, so I've got to divide this by 7. Okay, remember we only have to give our answer to one decimal place, so this is going to be fine. So 7 into 1 doesn't go, make it a 10. 7 into 10 goes once with 3. 7's into 39 go 5 times with a 4. 7's into 45, but it's 6 times 7 is 42, so it goes in 6 times with a remainder of 3. 7's into 36 go 5 times with a remainder of 1. 7's to 12 go in once. Okay, we can stop there. So it's going to be 156.5 because this bit here would just, the 1 isn't large enough to change the 5 to a 6. Okay, let's check on the calculator. So we have got here, what have we got? 8765 divided by 56. Okay, yep, and that's correct. Okay, right, this one here. Right. Okay, let's see if we can split up this 78. So 78 is 2 and 39. 39 is 3 and 13. Okay, which means that 78, well, we can divide this by 2, then we can divide it by 3, then we can divide it by 13. Let's just do that. Dividing by 2 is nice and quick. Okay, doesn't go. 6 goes in once, 1 left. 7, here we go. And then goes in twice. No, doesn't it? Goes in 3 times. Doesn't go. Goes in 6 times with 1 remainder. Goes in 5 times. Okay. Right, let me just move this over here. Okay. So now we're looking at 306.5 divided by 13. Okay. So into 3 it doesn't go. Carry that. 30 it goes twice, which is 26, which leaves a remainder of 4. Okay. Well, into 46 it goes in 3 times, which is 39. So 46 take away 39 equals 7. Okay, so we've then carried a 7. 13's into 75. Oh dear. Right, let's just count up. 13, 26, 39, 42, 52, 65. Okay, well it's going to be that. So we've got 65, which is 1, 2, 3, 4, 5 times. So 5 times with a remainder of 10. Okay, this looks like it could be quite high. 78, of course. 81, 91. Okay, so it will go in 1, 2, 3, 4, 5, 6, 7 times. So it's 23.57, which to one decimal place, this time, this rounds up. So this equals 23.6 to 1 dp. Okay, so let's double check that. 1, 2, 3, 4, divided by 78. Oh no! Oh dear, where did I go wrong? That is unfortunate. Okay, right, so Oh, I see where I went wrong. Here. I divided this by 2, where I meant to divide it by 3. So I did divided by 2, and then I meant to do this division by 3, and that's where I've gone wrong. Oh, that's annoying. Right. Back to the drawing board. Okay. So, here we go. We've got 3 here. 6, 1, 7. Maybe this will be nicer this time. That goes in twice. That doesn't go in. That goes in 5 times. And then there's a remainder of 2. 3 goes into 26 times with a remainder of 2. Ah, okay, it's one of these. Okay, so this would just go on like that. And then now let's see about dividing this by 13. 205.666. Okay, so it doesn't go into 20, it go once with a remainder of 7, because 20 take away 13 is 7. And 75, we got up to 65, didn't we? 1, 2, 3, 4, 5. So that's 5 times, and with a remainder of 10. And then 91 plus 13 would be 94, 104. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8 times here. So 0.8, yeah. And then that is with a remainder of 2. What? No, that can't be right. Because... Oh, no, that is right. Yeah, that is right. 2. Yeah. Okay, perfect. So that's exactly what they've got. So that would be 15.8 to 1 decimal place. Okay, great. Okay, right. This is there's more log. There's 10 more log division questions to come after this actually, but they're going all right. Okay, this one I want to show a quick trick for this one. So if I've got 9,012 divided by 90, or this is like 9012 over 90, I can divide both of these by 10 to get 901.2 divided by 9. And so now that's a lot easier to do. So I'm just going to divide this by 9. 901.2 divided by 9. So that goes in once, that goes in 0, that doesn't go in. There's one remainder, that goes in once with 3 remainder, that goes in 3 times with 3 remainder, and then that would do the same. That would just keep going in like that. But to 1 decimal place, that would be 100.1. Okay, so let's see that if that's correct. 9012 divided by 90. Excellent. So that agrees as well. Let me just underline these so that we can go and mark them now. So here we go. So where are we at? How to divide long numbers without a calculator. Practice 195.4, we agree. 145.4, we agree. 156.5, we agree. And 15.8, we agree. 100.1, we agree as well. Right, okay, now scenario questions. Okay, so here we go. Right, let me read these to make sure that they make sense. And this one here says, a farmer has 1,234 apples and wants to distribute them equally among 9 baskets. How many whole apples will be in each basket? That's fine. Sorry, I just wanted to check. I felt like we just had that question, but I don't think we did. I think that's fine. Yeah, no, we haven't had that. Okay, it's just the similar numbers. Right, okay, so let's keep going. So if we're sharing them equally among 9, sharing is just another word for divide. Distribute equally, this just means divide. Oh. Divide among 9 baskets. Okay, so let's go with this. 1, 2, 3, 4. Dividing it by 9. Okay. Yeah. No. 1, 2, 3. Oh, this is interesting. We don't actually have to go beyond into the decimals this time because it's asked how many whole apples will appear in each basket. So 9 into 64 goes 7 times. So the answer will just be 137 apples. Because there will be a decimal point, but it's not important because they've only asked how many whole apples will appear in each basket. Okay. Oh, let me check this though with the calculator. 1, 2, 3, 4. Oh yeah, well I did it the wrong way around. 1, 2, 3, 4 divided by 9. Yep, 137 apples. Okay, great. Let's try the next one. So here we have a bakery has 456 cookies and wants to package them in boxes of 4. How many boxes can they fill completely? So again, they don't want to know about the decimal here, if there is a decimal. We just want to do what we can. Okay, so 4, 1, 1. Oh, that's very nice. So let's find out what it says. So 4, 5, 6. Excellent. Okay. Right. A school has 675 students and wants to divide them equally into 25 classrooms. How many students will be in each classroom? Okay, so let's do that. I'm gonna, because 25 is quite nice to count up in. I'm actually just gonna. Am I gonna do that, or am I just gonna do 5 times? I'm gonna think about 25 as 5 times 5. So I'll do this by 5 once, and then I'll do it by 5 again. So that's 1, 3, 5, and then 1, 3, 5 by 5. That would be 0. That would be 2. That would be 7. That's good. They fit in perfectly. 27 students in each classroom. Okay, let's try. 675 divided by 25. Yep, perfect. They agree. Okay. Question 4. A construction company has 7,890 bricks and wants to stack them in piles of 55. How many complete piles can they make? Okay, again, I'm going to do 55 as 5 times 11, and then I'll divide this in sets. Okay, so let's do the 5s first. Okay, 7890 divided by 5. 1, 2, 5, 3, 7, 4, 8. Okay, and then we've got 1, 5, 7, 8 divided by 11. So doesn't go into 1, goes into 15 once with a remainder of 4. Oh, 11 times table is quite nice actually. Goes in 4 times with a remainder of 3. Goes in 3 times with a remainder of 5, but we don't need to bother with that because it just wants to know how many complete piles will you make. So that would be 143 piles of 55. Okay, in fact, I'm just going to write 143 piles. Let's check that with the calculator. So 7890 divided by 55, 143. Yeah, perfect. Okay, let's try this last one. A toy store has 9,876 toys and wants to display them all on shelves that each fit up to 30 toys. Okay, makes sense. How many shelves will they need to be able to put? How many shelves will they need to be able to put out all the toys? I think there needs to be a comma there. How many shelves will they need to be able to put out all the toys? How many shelves will they need to be able to put out all the toys? In order to put out all the toys. Yeah, I think there needs to be a comma. That doesn't read right for me. How many shelves will... Or I think this is just a funny phrase. Right, a toy store has 9,876 toys and wants to display them all on shelves that can fit up to 30 toys. How many shelves will there need to be? How many shelves will there need to be so that the toy store can put out all the toys? Okay, right. Sorry. So, what page was this one? 24. Right. A toy store has 9,876 toys and wants to display them on shelves that can each fit up to 30 toys. How many shelves will the toy store need How many shelves will the toy store need to be able to put... How many shelves will the toy store need if they... How many shelves will the toy store need if they want to put out all the toys? Okay, I think that's better. I don't know. That sounds right. Yeah, how many shelves will the toy store need if they want to put out all the toys? Or in order to put out all the toys? Sorry about this. How many shelves will the toy store need in order to put out all the toys? Maybe that doesn't need to be there. Where have I gone? How many shelves will the toy store need in order to put out all the toys? Yeah, that's fine. I'm happy. Right. Okie dokie, let's get back to business. Okay, right. So that's fixed. Wording changed. Okay. So 30. Okay, this is okay. So we can do the 9876 over 30 trick, which is 987.6 over 3. And now we can do this. 987.6 divided by 3. So that would be 3 into 9. That goes in twice with a remainder of 2. That goes in 9. Oh, this is interesting. How many shelves will they need to be able to put out all... How many shelves will they need to be able to put out... Maybe that was fine all along. Anyway, how many shelves will they need to be able to put out all the toys? Oh, I'm going to go back and change that. I like it now. How many shelves will the toy store need in order to put out... It's fine, actually. That's better. To put out all the toys. Okay, so they will need 329.2 shelves in order to put out all the toys, which I think means they'll need 330 shelves. Okay, right, let me just move that around. Here we go. Right, so they'll need 330 shelves. Let's just check that with the calculator. After all that wording stuff, it might have been the maths that went wrong. 9,876 divided by 30 equals 329.2, which would mean they would need 330 shelves. Okay, we can tick that here. Let's go back, and then we need to find this. There we go. Okay. Sorry about this. I feel like I'm faffing around, but I hope it's helpful. So here we go. We've got 137 apples. Yep. 114 boxes. Yep. 143. 27 students. Yeah. 143 piles. And 330 shelves. Excellent. Okay, right. 6 to 10. Right. A library has 2,500 books and wants to organise them on shelves with 12 books on each. How many complete shelves will they fill? Okay, so let's just divide it by 12. Okay, into 2 doesn't go, but into 25 goes twice with 1 remainder. In 10 doesn't go. In 100, how many 12s go into 100? 12 times 8 equals 96. Okay, so that goes in 8 times, and then we're into the decimals, so that's a 4. How many times does 12 go into 40? Goes in 3 times, with a remainder of 4 actually. Okay, so that'll be fine, that'll continue. But how many complete shelves can they fill? They can fill 208 complete shelves. Okay, and let me check that with the calculator. 2500 divided by 12 equals 208.3. Yeah, so that's fine. The calculator agrees. Let's have a look at question 7. So question 7 says a factory has 1,800 products and wants to pack them into boxes of 45. How many boxes can they fill completely? Okay, so I'm gonna split this into 5 and 9. Okay, I'm gonna actually divide by 9 first because I can see there's an 18 here, and I know that's gonna work out well. So 9 into 1 doesn't go. 9 into 18 goes twice, and then that just becomes 200. Okay, and then we've got 200 divided by 5. So 5 into 2 doesn't go, but that becomes a 20. 5 into 20 is 4 times, and so that'd be 40. So 40 boxes should be the answer. Let's just double check. 1800 divided by 40. Excellent. Okay, well, yeah, I did it the wrong way around, but the reverse calculations proved it is right. Okay, question 8. A supermarket has 8,766 cans of soda and wants to distribute them equally among 3 displays. Okay, so we're just dividing by 3 here, which is nice. 8,766. So that goes twice for the remainder of 2. That goes in 9 times. That's twice, that's twice. Oh, lovely. 2,922 cans per display. Let's check that that's right with the calculator. 8,766 divided by 3. Perfect. There we go. Right, we've got this one here. A classroom has 1,234 pencils and wants to distribute them equally among 27 students. How many will each student receive? Well, 27 is 9 times 3. So let's divide it first by 9 and then by 3. Okay. So that doesn't go. That there goes in once with a remainder of 3. 33 divided by 9 goes in 3 times to get to 27 with a remainder of 6. 9 into 64 goes in 7 times because that's 63. I will do a bit of this here, so that's 1, and then we'll do 2 lots of this. So 9 into 10 goes once with a remainder of 1. Oh, 9 into 10 goes once. Okay, so that's going to continue there. And now what we'll need to do is we need to divide this number by 3. Divided by 3. So into that doesn't go. Into 13 goes 4 times the remainder of 1. Goes 5 times with a remainder of 2. Oh, that's lovely. That goes in exact... Oh, but then the rest continues. That goes in 7 times. Okay, right. Okay, they want to... So you can't give somebody part of a pencil. So what we're going to have to do is we're going to have to stop at 45. So that'll be 45 pencils. Okay, and let's get the calculator out for that. So what we're going to have here, 1, 2, 3, 4, divided by 27. And that should, yeah, there we go, 45. Okay, let's do question 10, and then we can move on. So it says here, a warehouse has 9,012 boxes and wants to stack them in rows of 52. How many complete rows can they make? So, 52 is, well, it's 2 and 26, which is 2 and 13. Okay, so let's do divide 2, let's just do divide 2, divide 2, divide 13. Okay, so 9012 divided by 2 is 415,016. 4506 divided by 2 is 22153. And then we've got this divided by 13. 2253 divided by 13 is, well, it doesn't go into that. We carry the 2, 22 into 13. 13 into 22 goes once with a remainder of 9. And then we're just going to have to count up in 13s. 13, 26, 39, 42, 52, 65, 78, 81, 91. Okay, right, so into 95 it goes in 1, 2, 3, 4, 5, 6, 7 times with a remainder of 4. Into 43 it goes 3 times with a remainder of 4. Into 40, not that it's important, but into 40 it would also go 3 times. Okay, so what can we do here? We can stop here because they just want to know how many complete rows they can make. And so that's just going to be the 173. So 173 complete rows. Okay. Oh, some of those long division questions are really mean. Right, 9012 divided by 13. No, that wasn't what I wanted to do. 9012 divided by 52. 173. Yeah, here we go. So they agree as well. Now let's hop on over to the mark scheme just to check. So, right, so here we go. What have we got? We have got 208 shelves, 40 boxes, yeah, 2,922 cans, 45 pencils. Oh, they've given it extra information there, but it wasn't asked for, so that's fine. 173. Right, there we go. Oh, right. Oh my gosh. I've been going for so long. Okay, right. Still better keep going, otherwise I'll never get this done. So, okay, great. We are on a nicer topic again, okay? So, no worries, this will speed up. Okay, so here we go. Question 6, topic 6, how to make sensible estimates by rounding. Much nicer. Okay. So, I've put a note here, when estimating, round numbers to one significant figure, okay? It seems very counterintuitive at times, but it's what we've always got to do, because estimating is about making things really simple. It's not necessarily about accuracy, it's just about what you can do without having to think too much. So, this number, I'm rounding it to the nearest 10, so that's going to become 20. This number, I'm rounding it to the nearest 10 as well. And so that's what because the first significant figure is a 10. So that's going to be 60. And then I'm just going to do 20 add 60, which will be 80. Okay. So that's the answer for that one. Here we've got estimate the difference between these two. So 89.2 to the nearest 10 will be 90. 34 to the nearest 10. We don't really have to worry about the 6, but 34 to the nearest 10 is 30. So we've got 90 add 30, which will be 120. Okay. This one we're rounding to the nearest whole number this time, just because that's the first thing. The first significant figure is always the first number. So this one becomes 8, and this becomes 9. This word product is the result of multiplying two numbers together. So estimating the product of these is just to times these two together. So this will be 72. Okay. I could probably whip out my calculator for these if we wanted, but only if you need it. Here, estimate the quotient of 123.4 divided by 54. Quotient is not a word that we hear very often, but it's just the result of when something's divided by something. So this one is going to be, well, we've got to round this to the one significant figure. So this time this one goes to the nearest 100, which in this case is 100. And this one goes to the nearest 10, which means that it's 50. 100 divided by 50 is nice, that equals 2. Okay, right. Estimate the sum of 456 points. Okay, right, so again, this is 100, so we're going to round this to the nearest 100. So we always look at the second number, so this is going to become 500. This one will become 800. So then the sum is then added together. So let's just do that here. 0, 0, 3, 1. There we go. And we can then mark these. That's nice. That was a lot quicker than the long division. Right, here we go. Right, so what have we got? Yep, 20 add 60 is 80. It's always important to put you've got to write your working out bits here, because otherwise they won't know what you've been up to. What have I got here? 90 add 30. Oh no! Ow, damn it. It said difference. I accidentally took it away, added them. So they are correct. Let me just change that here. I need to change that. Change that. Change that. I was just being too haphazard. But they are correct. Well, wonderful. Right. Next bit, 8 times 9 is 72. Yeah, well done. We agree with that. 100 divided by 50 is 2. We agree with that. 500 plus 800 is 1,300. We agree with that. Okay. Right, on to question 6. Right. Right, difference. Remember that. Takeaway. Okay, so 678 will become 700. 901 will become 900. So look at 900 take away 700, which will be 200. Okay. Product is multiply. This time it's to the nearest whole number, so that's going to be 2. 4.5, 5 rounds up, so that's going to be 5. So 2 times 5 is 10. Quotient is the result of when you divide things. So we've got, this will be to the nearest 100, so that's going to be 600, divided by, that will be to the nearest 10, but that will actually make it 100. Okay, so that will give us 6. Estimate the sum of these, so this will be 900, this will be 200. Sum is when you add them, so we've got 900 add 200, 0, 0, 11. There we go. And then we've got another difference here, which means take away. So that's 300 for this one. This becomes 700. So we're looking at 700. Take away 300. And that will be 400. Right, okay, let's mark these. So here we go. 900 take away 7. Yep, very good. Excellent, we agree. Yep, we agree here as well. We agree here too. And we agree here as well. Excellent. Oh, right, that was a nice quick round. Okay, now let's look at the scenario questions for these. So here we go. Right, let's have a look at what's going on. So what we have here is we've got scenario. Okay, right, I need to read these to make sure that they make sense. Okay, so estimate the total cost of a hamburger, fries, and a drink if a hamburger costs £5.29, fries cost £2.99, and a drink costs £4.49. Right, so remember, we're rounding everything to one significant figure. Okay. Oh, what's that? Here we go. Okay, so remember this is all to one significant figure. So we've got £5, add £3, add £4. 5 and 3 is 8, add 4 gets us to 12. Okay, question 2. If a movie ticket costs £17.99, popcorn costs £5.89, and a drink costs £3.09, estimate the total cost of going to the movies. Okay, so that's going to be £20 for the first one, plus £6 for this one, plus £3 for this, which is going to equal £29. Okay. Next one. Estimate the total cost of buying a t-shirt for £45, a pair of jeans for £87.99, and a pair of shoes for £91.99. Okay, so 45 rounds up to 50. 87 rounds up to 90. And 90 will round up, 91.99 will round up to 90 as well. Remember, one significant figure means we only have one non-zero number in all of these. So we've got 90, add 90, which is 180. And then we've got 180, add 50, which will be 230. So the answer will be £230. Okay, so that's going to be our estimate for that. Next we've got here is if a book costs £10.99, so that will round to £10. A notebook costs £2.50, so that will round to £3. And a pen costs 79 pence, so that will round to 80p, 0.8 pounds. Estimate the total cost of the supplies, so this will equal £13.80. Right, okay, let's have a look at question 5. So question 5 says, estimate the total cost of buying a pizza for £12.60, a salad for £4.80, and a dessert for £5.40. So what we have here is we're going to have £10 plus £5 plus £5, and that will equal £20. Okay, right. Let's mark these. Okay, let's get these marked. Okay. Okay. Okay, 5 add 3 add 4 equals 12. Nice. 20 add 6 add 3 equals 29. Great. I'm just looking here. Yeah, 50 add 90 add 90. Oh, wonderful. 10 add 3 add 80 is this. Yeah. Excellent. Okay. Oh, a lovely quick round. Right, I need to fill up my drink bottle again. I'll be back very quickly. Hello. Sorry about that. Right, so let's continue with these questions. Okay, so what we've got here is okay, on a day out, Kaz bought a bus ticket costing £2.50, a train ticket costing £42.50, and a taxi ride costing £10.83. Estimate the total cost of transportation for a day. Okay, that's not right. On a day out, it should just be like for the day out. For the day. That should be the... Alright, let's just change that. Okay, 1 second. On a day out, Kaz bought a bus ticket costing £2.50, a train ticket costing £42.50, and a taxi ride costing £10.83. Estimate the total cost of transportation for the day. Okay. Let's move back. Okay, and let's answer this question. So, the bus we're going to say is £3. The train is going to be £40, and the taxi ride will be £10. Okay, so 40 plus 10 is 50, and then with the 3, so that will equal £53. Okay, I'll just make a note here. Changed wording. Okay. Right, question 7. Estimate the total cost of buying a laptop for £645.99, a tablet for £309.99, and a smartphone for £879.99. Okay, so these are to the nearest 100. So we've got 600 for the laptop plus 300 for the tablet plus 900 for the iPhone, the smartphone, sorry, no brand loyalty, be the worst paid promotion ever. Right, 300 add 600 is 900, 900 add 900 would be 1,800, so that's 900 add 900 is 1,800. Okay, let's try here. If three concert tickets cost this much, $279.99. Estimate the total cost of one ticket to the concert. Okay, well, this is roughly 300, and there's 3 of them, so we're doing 300 divided by 3, so that would equal £100. Okay. Estimate the cost of buying one shirt if 12 shirts cost this. Okay, so let's round these numbers. 1's fine. We're going to say that this is 10 and this is 300. So we're looking at 300 divided by 10, which will be 30. Okay, and we should put that in money. So £30 for one shirt. Okay, right, question 10. If over 1 year Cher's coffee spend is £829, estimate how much she spends a day. Right, so so in a year there's 365 days. Okay, so that's going to go to 400. Okay, and the coffee spend is 829, so that's going to go to £800. So we're going to do 800 divided by 400, and that's nice and easy. That would be 2. So it'll be £2 per day. Okay, great. Right, let's continue. Let's get this marked. Okay. So here we go. Right. So, where are we up to? Scenario here. Okay. Yep. 3, 40, 10, 53, 600, 300, 900, 1,800. 300 divided by 3 is 100. Yeah. 300 divided by 10 is 30. £30 for one shirt. And 800 divided by 400 is 2. So that's £2 per day. Okay, great. This is going well. Okay, right. On to number 7. Okay, so let's keep going with this. Right. So evaluate the expression x plus 5 when x equals 4. Okay, so that's just going to be 4 plus 5. So that will equal 9. We just replaced the x with the 4. That's what's happened. Find the value of 3y plus 7 when y is 2. So that means that we're doing 3 times 2 plus 7. 3 times 2 is 6. 6 plus 7 equals 13. Okay. Next, what we have is a is 5 and b is 2. So that's 4 times 5 for the 4a, which will equal 20. And then 2 times 2 for the 2b part, which will be 4. And then we're taking the second part away from the first part. So we've got 20, take away 4, which will be 16. Okay. Evaluate the expression for this. Well, we've got 2 times x plus y. So x is 3, y is 7. So we've got y is 4. 3 plus 4. And then we're taking away 3 times z, which is 2. Okay, so we've got 2 times 7, take away 6. 2 times 7 is 14. 14 take away 6. And that will equal 8. Okay. Let's try here. 2x is 2, y is 5. This squared thing, so this is like 2 squared means 2 times 2. So that would be 4. Okay, so that bit is worth 4. And then 2y equals 2 times 5. Okay, so that would be 10. So we have got 4 plus 10. So that will be 14. Okay. Right, let's get those things marked. Okay. Okay, so here we go. We've got, 9, 13, 16, 8, 14. Excellent, brilliant. Okay, all agreed. All right, let's do the next round. Okay, find the value of the expression 2a minus 3b plus c squared when a is 4, b is 2 and c is 1. So 2a is 2 times 4, okay, minus 3b, which is 3 times 2, plus c squared, where c is 1, so that's just 1 times 1, okay. So 2 times 4 is 8, take away 3 times 2 is 6, plus 1 times 1, which is 1, okay. So 8 take away 6 is 2, so we get 2 plus 1, and that will equal 3. So the answer to this is 3. Right, the next one here, we've got 3 lots of x minus y. X is 5, y is 3. So 5 minus 3 equals 2. So that means we've got 3 lots of 2. So 3 times 2 equals 6. So the answer to this question would be 6. Right, next one here, we've got find the value of 2y squared plus 5z. Right, whenever the squared here is attached to the y, so what we have to do is we have to multiply the y by itself first before we can times it by the 2. So if y squared equals 3 squared, that equals 3 times 3, which equals 9. So we have 2 of these 9s. So we've got 2 times 9 plus 5 times 4. 2 times 9 is 18. 5 times 4 is 20. So the answer to this bit will be 38. Okay. Right, evaluate the expression 2a plus 3b minus c squared. Okay, right, so 2a is 2 times 1. 3b is 3 times 2. And then minus c squared, so that's c squared is c times c, which will be 3 times 3. Okay, so 2 times 1 is 2, plus 6, and then minus 9. Ooh, we're going to go into negatives. 2 plus 6 is 8, so we've got 8 minus 9, which will be minus 1. We don't get many negative numbers here. Right. Question 10. Evaluate this expression 5 bracket x plus y minus z when x is 3, y is 4, and z is 2. Okay, so let's do... oh no. Right. Let's do the x plus y first. So x plus y is 3 plus 4 is 7. So we've got 5 lots of the 7. Take away the z. 5 times 7 is 35. Take away 2 equals 33. Okay, right, let's get this marked. Right, so we've got 3. Excellent, we agree. We've got 6. We agree. We've got 38. We agree. We've got negative 1. We agree. And we've got 33. So we agree with that as well. Okay, wonderful. Right. So, next thing is... Yep, in scenario form. Okay, so let me make this big. Okay, right. So, I need to read these carefully so that they make sense. The area of a rectangle is given by the formula A equals length times width. If the length is 5 meters and the width is 3 meters, I don't like this. I don't like it that this is here. I think like that needs to be on one line. And I don't like that doesn't say area. Okay. they either have to all be words or all be things. Okay, so if the length is 5 meters and the width is 3 meters, what is the area of the rectangle? Okay, so let's go, first of all, let's change that. Right. Maybe if I just write area here, and then if I just press equals. Oh, no. Oh, no. Oh. Oh, it's done it. It's done it. It's done it. This is all good. That is how I want it. Perfect. Okay. Okay, so there we go. So that's sorted. Okay, so we just want to use the formula. Length is 5, width is 3. So area equals 5 times 3, which equals 15 meters squared. Okay. I'll write it like this. Maybe I need to state that it's the area of a rectangle in square meters. I don't know. I think it's fine. Okay. Right. Question 2. The speed of an object is given by the formula speed equals distance divided by time. If a car travels 200 kilometers in 4 hours, what is its average speed? Okay, so it's going to be 200 divided by 4, which will be 50, and that will be kilometers per hour. Okay. The volume for the formula of a cylinder, the volume of a cylinder is given by the formula V equals pi r squared h, where pi equals 3.14, r is the radius and h is the height. If the radius is 2 meters and the height is 6 meters, what is the volume of the cylinder? Okay, right, this is fine because V is written like this, and this is all symbols. Okay, so I like this. Right, so what we've got is we have volume. So pi is 3.14 times the radius, which is 2, and that's squared. Okay, so that's 2 times 2 times the height, which is 6. What is the volume? I'm actually just going to use the calculator to do all this because this feels like a calculator question. 3.14 times 2 times 2, so that's the 2 squared, and then times 6. Okay, which equals 75.36, and that will be meters cubed for this one. Do I need to put what is the volume of the cylinder in meters cubed, or is it fine? Right, I think it's fine. Question 4. The simple interest received is given by the formula I, which is presumably interest, equals P times R times bracket R divided by 100 times T, where P is the principal amount, R is the interest rate, and T is the time in years. If the principal amount is £1,000, the interest rate is 5%, and the time is 2 years. Use the formula to calculate the simple interest received. Okay, let's do it. So the interest equals the principal amount, which I've been told is 1,000, times bracket the interest rate, which is 5, divided by 100, and then times by 2. I'm just going to work out this bracket first, okay, and then we can just times everything together. Okay, so 5 divided by 100 equals 0.05. So I'm just going to now do 1000 times 0.05 times 2. So here we go. 1000 times 0.05 times 2. Ah, that's nice. So that equals 100. And that would be pounds. So it'd be £100 of interest. Okay. Right. Next one. The area of a circle is given by the formula A equals pi r squared, where pi equals 3.14 and r is the radius. If the radius is 7 centimetres, what is the area of a circle? Okay, so we've got pi, which is 3.14, multiplied by the radius squared, which means 7 times 7. Okay. I just put a little note to say 7 squared. And then multiplied by, oh no, that's it. It's just pi r squared. So 3.14 multiplied by the 7 times 7. Okay, so let's get out the calculator. So here we go, 3.14 times 7 times 7. Okay, so that equals 153.86 centimetres squared. Okay, right, let's get marking. Okay, so here we go. Okay, so I need to oh no, that's not what I wanted to do. I was about to mark it until I've been going for a while. Right. Okay, so let me roll this up. So substitute into formula, Sinat. No. Here we go. 15 square meters. Yep, we agree. 50 kilometers per hour. Yep. 75.36 cubic meters. 100 pounds. And 153.86 centimeters squared. Okay, great. Thank you. So let's keep going. Right, the perimeter of a square is given by the formula P equals 4s, where s is the length of one side. If the side length is 10 meters, what is the perimeter of the square? Okay, so P equals 4s. So we've got here that the perimeter equals 4 times the side. The side is 10, so 4 times 10, which will be 40, and that'll still be in meters because perimeter is still a length. Okay. The Fahrenheit to Celsius conversion formula is C equals F minus 2 divided by 1.8. If the temperature is 68 degrees Fahrenheit, what is the temperature in Celsius? I need to put in this bit. I need to put in the where F is the temperature. Maybe it's I think I need this bit here, where F is the temperature in Fahrenheit. Oh no. If the temperature is 68 degrees Fahrenheit, so we've got C equals 68 minus 32 divided by 18. Okay. Oh no, not divided by 18, divided by 1.8. Okay, there we go. Right. Question 8. The body mass index, BMI, is calculated using the formula BMI equals weight divided by height squared, where weight is in kilograms and height is in meters. If a person weighs 70 kilograms and their height is 1.75 meters, what is their BMI? Okay, let's do this. Okay, so we've got here, we always have to do the squaring first, unless there's brackets involved before. But so let's do the height squared first. So height squared equals 1.75 times 1.75. Okay, so we've got 1.75 times 1.75. Okay, so that equals 3.0625. And so then we've got the BMI will equal their weight divided by this height squared, like this. So we've got 70 divided by 3.0625. And 22.8, let's say 86. I think I actually want to add here, I'll check with the answers, what is their BMI to 1 decimal place? Because I don't think that's been talked about, and I think it's misleading if we don't have it. Oh no, give answers up to 2 decimal places. Okay, that's fine. It's been covered, so that's fine. So actually ignore that. 22.86 is the perfect answer. Okay, so let's just underline our answers here and here. Okay, right. Question 9. Let's do this one. We've got the same issue here as well. This one's not been well formatted. So I need to go for area here, if we've got base and height there, and then this needs to be on the same line as that. So let's sort that out. I actually think I'm going to press equals here. Just doesn't sit well with me having the number under the number. Right, that's fine. That's just a formatting thing. Right, the area of the triangle is given by the formula area equals half base times height. If the base is 8 meters and the height is 5, what have we got? So we've got a half times base, which is 8, times height, which is 5. Okay. If you don't know how to calculate, how to type in the fraction on your calculator, you can just do 1 divided by the top divided by the bottom. So here we go. So this is actually a half is the same as 0.5. Okay. You might have a calculator. You probably do actually have a calculator which has a fraction button on it, which is very useful. So, but let's just type these things in. 0.5 times 8 times 5, and that equals 20. And that would be meters squared in this case. Right. I'll just put that in red there to say that's been done. Okay. Next bit here, we've got discount amount is given by the formula. Discount equals original price times discount rate divided by 100. If the original price is £50 and the discount rate is 20%, what is the discount amount? Okay, so we've got the discount is equal to the original price, which is 50, times the discount rate, which is 20, and then divided by 100. Okay, so there we go. We can do this on the calculator. So we've got 50 times 20 divided by 100, and that equals 10, and that would be pounds. Okay, here we go. Let's mark this round. Okay. Okay, let's go to the top. So 40 meters, we agree. 20 degrees, we agree as well. I actually think that should say 20 degrees Celsius, just in case there's confusion there. Okay. Yeah, 22.86, 20 meters squared, and £10 discount. Okay, great. Right. We're storming through now. Right, convert fractions to decimals. So here we go. Oh, I didn't want it to go that large. Right, so here we go. So fractions to decimals is basically you're just doing the top number divided by the bottom number. You can do it using long division or the bus stop method, or you can just use a calculator. So 3 over 4 is 3 divided by 4. So this one's 0.75. 5 over 8 is 5 divided by 8. Right, I've said here, give your answers up to 3 decimal places. Okay. So here we've got 2 divided by 3. Oh, we should round it though. If it's 3 decimal places, we should round it to 3. You know what? I'm actually going to do this 0.6 with a dot. This dot means recurring, which means that the 6's go on forever and ever. That's the correct way of writing the equivalent to 2/3 as a decimal. But I suspect due to the difficulty of getting this dot, in the mark scheme I've probably done this, which is it correctly rounded to 3 decimal places. Okay, here what we've got is we've got 0.7, a half is 0.5, you might know that. Okay, let's mark these. Okay, let's check that these are all correct. So we've got here 1 is 0.75, 0.625, yeah, 0.677, 0.7, 0.5. Great. Next round. Okay. Right, 4/5. Here we go. So 4 divided by 5. I should probably write these. 3/7. Just put a note there to say that I've rounded it to 3 decimal places. 9 divided by 16. Let's do that here. 9 divided by 16. So that equals 0.5625, which would be equals 0.563 to 3 decimal places, which is what I've requested it for. 5 divided by 6, let's find what that is. 5 divided by 6 equals 0.8333, which will be 0.833 to 3 dp. And then lastly here we've got 2 over 9, which is 2 divided by 9, which is 2 divided by 9, which equals 0.222 to 3 decimal places. Okay, right, let's get these marked and checked. Okay, so where are we? Right, so 0.8, 0.429, 0.563, 0.833, 0.222. Okay, great. Right. Oh my gosh. 10% of the way through, roughly. Just looking at the book number, which says 35. But that's not true because it started a bit later because of the contents. Right. Okay, right. Scenario questions. Let's have a look at these. Again, give your answer up to 3 decimal place. These are really, these ones, there wasn't a particularly snazzy way of putting these into questions. But it's just seeing if you can pick out the question from the words. So, in a pizza party, 1/8 of pizza is left. What is this fraction as a decimal? So again, we'll just do 1 divided by 8. And then we can write that down here. So here we go. 1. 0.125. Okay. A recipe calls for 2/5 of a cup of flour. What is this fraction as a decimal? So that's going to be 2 divided by 5. Which will equal 0.4. Okay. A tank is filled with 1/6 of its capacity. What is this fraction as a decimal? So 1 divided by 6 equals, let's find out. 1 divided by 6 plus 0.1666. Okay, so it's 0.166. They want it to 3 decimal places, don't they? So 1.167. See. Okay. Next bit we've got here. A student correctly answers 9 out of 10 questions on a test. What is this fraction as a decimal? So that's 9 out of 10. So 9 divided by 10 equals 0.9. A store is offering a discount of 1/7 on all items. What is this fraction as a decimal? So 1 divided by 7. Let's find out. So we've got here 1 divided by 7. There we go. 0.1428, which will be in the 3 decimal places situation. 1.143. Okay, let's get this marked. Right, next page. Here we go. Woo! It's always nice to be on a new page. Okay, so we've got (0.125), 0.4, 0.167, 0.9, 0.143. Oh no, that's that. One sec, I'll be back shortly. Right. I'm going to get up to 10 for today, and then we'll stop. Right, so. Right. That's that all done. Right, next page. Right. Sorry. There's one more. A marathon runner has completed 3/5 of a race. What is this fraction as a decimal? Okay, 3/5, 3 divided by 5, it equals 0.6. Okay. A group of 9 friends shared a pizza equally. What is the fraction each received as a decimal? Well, if they've all got a 1/9 of the pizza if they shared it equally between 9 of them. So that's 1 divided by 9. Let's whip out the calculator again. So here we go, 1 divided by 9 equals 0.1. Okay, right. Next bit, a car travelled 9/20ths of a total distance. What is this fraction as a decimal? So we've got 9 divided by 20. Here we go, 9 divided by 20. 0.45. A cake recipe requires 4/5 of a cup of sugar. What is this fraction as a decimal? Not 4/5, 5/6. 5 divided by 6. Okay, let's do 5 divided by 6. 0.833. Okay, I'll put to 3 decimal place there. A survey found that 2/25 of the participants preferred chocolate ice cream. What is this fraction as a decimal? So that's 2 divided by 25. And let's find out. 0.08. Right, let's get these marked. Okay. 0.6, yeah. 0.1111. I'm looking over here. 0.45. 0.833. 0.08. Excellent. Yay! On to number 9. Right. Okay, right. Convert 25% into a fraction and a decimal. Right. Any percentage is a fraction over 100. So 25% as a fraction is 25 over 100. Okay. Now, this can be simplified, but for this topic, the purpose of this round of questions is actually to just practice the skill of turning it into the fraction without worrying too much about simplifying it. There is another activity later on where you need to concern yourself about simplifying. If you do want to simplify it, that's fine, but if you don't worry. Yeah, let's just see. Actually, what I'm going to do is I've got my calculator here. I'm going to type these into my calculator to simplify them, and yeah. Anyway, so we've got 25 over 100, and that equals 1/4. Okay, and then as a decimal, we can just do 1 divided by 4. Well, we don't have to. We could actually do 20. Let's do it this way. We'll do 25 divided by 100. Which equals 0.25. I did that on the calculator just to remind yourself how to do it. But the other way, you'll start to see the pattern. It's kind of like if you divide by 100, it's the decimal point that moves around, so the numbers stay in the position. But we'll push on with these. So 2% is 2 over 100, which is also equal to 1 over 50. And then 2 divided by 100 is equal to 0.02. So we've got here, let me just underline, we've got all of these things are acceptable answers. Okay, all right. 75% is 75 over 100, which is actually also 3 over 4. 75 divided by 100 equals 0.75. So here you go, all these things are acceptable answers. 10% is 10 over 100, which is also equal to 1 over 10. And then as a decimal, that's 10 divided by 100, which becomes 0.1. Right. Convert 3.5 into a fraction and a decimal. Well, 3.5 would be 3.5 over 100. You can't actually have that because you can't have decimals and fractions together. So this becomes 35 over 1,000. If I type this into my calculator, it will sort it out for me. And that's 7/20. That's what it says. And then as a decimal, you've got 3.5 divided by 100. 3.5 divided by 100 is, well, it moves 1, 2, so that'll be 0.035. Okay, let's mark it. Okay, right. Yeah, so we've got the or equivalents here. So I've written a quarter or equivalent. I think this is fine. So I've put the simplified version as the answer, just because there ends up being a plethora of things that it could be. Oh, I got this one wrong. There we go. But they're all alright and they all agree. I think that'll be fine. Let's... Right, sorry, I've been munching on M&Ms. Right, let's get cracking with these ones. Okay. So, in a class of 30 students, 20% are girls. What is this percentage as a fraction and a decimal? Okay. 20% is, I've put a different number here just to throw you off, because often there's different numbers in questions, so you just need to kind of focus on what the key information there are is. So it's just the 20%. They don't want the 20% of the 30, they just want to know what is this percentage, what is the 20% as a fraction and a decimal. So 20% is 20 out of 100, which is 2 out of 10, which is 1/5. Okay, or we can do 20, that's for the fraction. 20 divided by 100 equals 0.2. Okay, so here we go. We've got our two answers there, but they haven't said in their simplest form, so you can use equivalents. That's absolutely fine. Part 2, question 2 says, a store is offering a 25% discount on all items. What is this percentage as a fraction and a decimal? Well, it's 25 out of 100. And you might know that 25% is a quarter. Okay, as a decimal, we're going to do 25 divided by 100, and that will equal 0.25. Okay, let's look at question 3. So in question 3, we've got, in a survey, 60% of the participants preferred chocolate ice cream. What is this percentage as a fraction and a decimal? So we've got 60%, which is 60 over 100, which we can simplify to 6 over 10, which could be 3/5 as well. As a decimal, we are going to have 60 divided by 100, which becomes 0.6. A company donated 15% of its profits to charity. What is this percentage as a fraction and a decimal? So as a fraction, remember it's 15 out of 100, that's what a percentage is. We could probably simplify these by dividing both by 5. So this becomes 3 out of 20. Okay, and then 15% is 15 divided by 100, and that will equal 0.15. Okay, right. In a basketball game, a player made 40% of their free throws. What is this percentage as a fraction and a decimal? So, as a fraction, it's 40 out of 100, which is equal to 4 out of 10, which we could say is 2/5. Remember, they haven't specified simplifying. As a decimal, we get 40 divided by 100, which will be 0.4. Okay. Let's get these marked. Okay, so where are we up to now? Ah, there we go. Right, so we've got 1/5 or equivalent, 0.2. A quarter or equivalent, 0.25. 3/5 of equivalent, 0.6. 3/20 are equivalent, 0.15. Oh, no. Yes. Here we go. 2/5 or equivalent, 0.4. Right. Okay, here we go. Sorry, I needed to read this out. A test has 10 multiple choice questions and a student answered 80% of them correctly. What is this percentage as a fraction and a decimal? A recipe calls for 30% less sugar than the original amount. What is this percentage as a fraction and a decimal? In a survey, 70% of the participants agreed with a statement. What is this percentage as a fraction and a decimal? Okay. A company increased its prices by 5%. What is this percentage as a fraction and a decimal? Okay. A store sold 90% of its inventory during a sale. What is this percentage as a fraction and a decimal? Okay. I don't know, I feel the need to underline them all, but it's nice to underline your answers. Right. So, we are here. 4/5, 0.8. 3/10, 0.3. Yeah. 1/20, 0.05. 9/10, 0.9. Okay, right. Round 10. Turning decimals into fractions and percentages. And I've promised myself at the end of this we can stop. Right. So. Right. So. 0.5 is a fraction, so that's 0.5 over 1 plus 5 over 10. Yeah, well, it equals a half as well. These are all, these are both acceptable. 5/10 and 1/2. You might just know some of these as well. Okay. Sorry, I haven't been reading these out. Convert 0.75 into a fraction and a percentage. We're going to have, well, it's going to be, let's do it to the percentage first, actually. So 0.75 times 100 equals 75%. We know that 75% means 75 out of 100. So there we have it as a fraction. But you also might know that it's 3/4 as well. So 0.1 times 100 equals 10%. 10% is 10 out of 100 equals 1/10. So we've got these two. Convert 0.2 into a fraction and a percentage. So we've got 0.2 times 100 gives us 20%. Okay, and then 20% is 20 out of 100, which would simplify down to 2 out of 10, which would simplify again to 1/5. Okay, right, let's mark these. Okay, so we've got here a half, yep, 50%, a quarter, 25%. We've got 3/4, 75%. We've got 10%, 1/10. We've got 20%, 1/5. Very good. Let's do this next round. Okay, so let's convert to a percentage first and then turn to the fraction. So 0.4 times 100 equals 40%. Then we've got 40 out of 100 equals 4 out of 10 equals 2/5. Okay, convert 0.6 into a fraction percentage. So 0.6 times 100 equals 60%. 60% is 60 out of 100 equals 6 out of 10 equals 3 out of 5. Okay, then we get 0.8 times 100 equals 80%, and that's going to be 80 out of 100 as a fraction, which equals 8 out of 10, which equals 4 out of 5. And then we've got here 0.05, so 0.05 times 100 equals 5%, and that will be 5 out of 100 as a fraction, which also equals 1/20. And then we've got 0.9 times 100 means it's 90%, which means that's 90 out of 100 as a fraction, which is also 9 out of 10. And then that doesn't simplify anymore. So let's mark these. Okay, so we've got here, where are we? Oh! I've done that. 1 second, sorry, I'm losing it. Here we go. 2/5, 40%. 60%, 3/5. 80%, 4/5. 1/20, 5%. Oh. 90%, 9/10. Ah, right. Just a scenario one's left. Okay, so here we go. Right, so here we go. It says here, turn decimals into fractions and percentages. Scenario questions. And question 1 says, in a class of students, the probability of being male is 0.75. What is this decimal as a fraction and a percentage? Okay, so let's do the percentage first. I know they've said it was second, but it's a bit easier. So 0.75 times 100 means that's 75%. Okay, 75% is 75 over 100, which is also 3/4. Okay, a store is offering a discount of 0.2 on all items. What is this decimal as a fraction and a percentage? 0.2 times 100 equals 20%. 20% means 20 over 100, which is the fraction. It's 2 over 10 equals 1/5. Okay, in a survey, 0.6 of the participants preferred chocolate ice cream. What is this decimal as a fraction and a percentage? Well, that is going to be 0.6 times 100 equals 60%. Okay, and then we've got 60% means 60 out of 100, which means 6 out of 10, which means 3 out of 5. Okay. A company donated 0.15 of its profits to charity. What is this decimal as a fraction and percentage? 0.15 times 100 equals 15%. Okay, 15% means 15 out of 100, so that's that as a fraction. These both divide by 5 and become 3/20. So you can have this as well. In a basketball game, a player made 0.4 of their free throws. What is this decimal as a fraction and a percentage? 0.4 times 100 means that's 40%. 40% means 40 out of 100, so that's that as a fraction. But we can simplify it down to 4/10, and then we can go to 2/5. Okay, let's get these marked. Okay, so yeah, scenario here. So we now have 75% 3/4, 20% a fifth, 60% 3/5, 3/20, and 15%, 2/5, and 40%. Okay, so they all match up with here. Let's do the last page. Well, the last section for today, which will be section 10, part 2. Okay, a test has multiple choice questions. A student answered 0.8 of them correctly. What is this decimal as a fraction and a percentage? So we'll do 0.8 times 100, which will tell us that that will be 80%. 80% is just a fraction over 100, which is 80 over 100, which can simplify down to 8 out of 10, which can simplify down to 4/5. Question 7. We've got here, a modification to a recipe calls for a reduction in the sugar content by a scale factor of 0.3. What is this reduction as a fraction and a percentage? Well, 0.3 times 100 means that that is 30%. Okay, and then remember, percentage means fraction out of 100. So 30% is 30 out of 100, which is also equal to 3 out of 10. Right, question 8. In a survey, 0.7 of the participants agreed with a statement. What is this decimal as a fraction and a percentage? Well, that is going to be 0.7 times 100 turns it into that percentage, which will be 70%. And then 70% really is just a fraction over 100, which means 70 out of 100, which we can then simplify to be 7 out of 10. Okay. Right. Question 9, we're going to have a company increased its prices by a factor of 0.05. What is this decimal as a fraction of a percentage? Well, 0.05 times 100 equals 5%. And remember, 5% means 5 out of 100 as a fraction, which would simplify down to 1 out of 20. Okay, question 10. A store sold 0.9 of its inventory during a sale. Write this decimal as a fraction and a percentage. So we get 0.9 times 100 equals 90%. Okay, and then 90% is just 90 out of 100, which we can simplify down to 9 out of 10 if we need to. Okay, right. Let's get this marked and then let's call it a day for today. Okay, so we are going to mark these ones, and we have got 80%, yes, 4/5, yes, 30%, 3/10, 70%, 7 out of 10, 5%, 1 out of 20, 90%, 9 out of 10. Okay, great. Right, well, thank you so much if you have watched all that. I'll put this up here just quickly to remember. Remember, the purpose of me doing this is I'm doing my final proof check for the Crack Maths book that is coming out. It is basically just all the sheets that you can find on the website. Everything that you've done today is available on the website anyway, and there are tutorials and things for that can give you a bit more detailed of all of that stuff. So anything you want to do with that, please please just take a look. Other than that, that's that. So thank you very much, and I will be doing another one of these shortly to check again on the things for I'm so tired to check again on the things on the lessons for on the book and the notes for tutorials 11 to 20. Okay, cool. Right. Thank you very much and see you soon. Bye.